Okay, so I can ask another example of the same kind of question. So instead of calcium, let's use another element. So we're going to use the element strontium. So in your periodic table, it looks like this. And then I can ask the question, if I have 128.79 grams of strontium, how many moles of strontium do I have? I can ask that question, and then I can also ask for 128.9 grams of strontium, how many atoms of strontium do I have? Okay, so for this we're going to have to do a little bit of math. So what we're going to do is we're going to look at the conversion factor. So the conversion factor that we're going to use is, I'm going to write the conversion factor as a nice long line. So we're going to say 1 mole strontium is equal to 87.62 grams of strontium is equal to 6.022 times 10 to the 23rd atoms of strontium. So there's my long line conversion factor. So we look at what we have, and we see that we have 128.9 grams of strontium, and you would like to convert it to moles. So what we're going to do is we're going to start out with the mass of the strontium that we have. So we got 128.9 grams of strontium, and we're going to multiply it by a conversion factor. Now, there are two possible conversion factors. I would like to end up in moles, so I'm going to end up with moles at the end. So I'd like to end up with moles on the top at the very end, the very final calculation. I'd like to end up with moles. And then I'm going to have grams on the bottom here to cancel out the grams. And if I look at the conversion factor that I have available, you can see that I can use this as my conversion factor. Now if I'm going to use this, I've got an equivalent. 1 mole is equivalent to 87.62 grams. I can either write 1 mole over 87.62 grams, or I can write 87.62 grams over 1 mole. So let me show you what that would look like. So I can write either 1 mole strontium over 87.62 grams of strontium, or I can write 87.62 grams of strontium over 1 mole of strontium. So I have those two options. So I look at those two and I think to myself, now which one of those would I like to use? So I have either this, which I'll call A, and I have this, which I will call B. Now I look at these two and I say to myself, okay, I need to cancel out the grams. So I got grams on the bottom here, I got grams on the top over here. So which one am I going to use, A or B? And you're going to say, well, I'm going to use A, because I'm going to have grams of strontium on the bottom. Okay, so I'm going to say 87.62 grams of strontium on the bottom, and I'm going to end up with 1 mole of strontium on the top. Now let me cancel out what I can. So I've got grams of strontium and grams of strontium, and what I have left after that is I have a mole of strontium still left. I can go ahead and put that into my little calculator. So here it goes into my little calculator. I'm going to put in 128.9 and then divide by 87.62, and I'm going to end up with 1.471 mole of strontium. Okay, now how many significant figures do I have? I could have actually used more significant figures in the strontium. well, actually, my periodic table only had 4 significant figures, but my original number that I was given had 4 significant figures, so I had to have no more than 4 significant figures in my final number because I'm doing a multiplication division problem in this case. Okay, now you might want to actually see if you can do the other calculation for converting from grams of strontium to atoms of strontium. So this is 1.471 moles. Sorry, I already have the moles written there. And I'd like to know how many atoms of strontium I have for that same amount. So if I want to do that, then I'm going to use my other conversion factors. So I've got atoms to grams. So I can actually go directly from that to that, or I could just take the number of moles that I have and then convert that to number of atoms. So I can go 1.471 moles of strontium, and there are, in 1 mole of strontium or any element, there are Avogadro's number of atoms. So then I just have to multiply that number through, and I will get the number of atoms of strontium. I'm going to suggest that you go ahead and do this little bit of math and see what you get for this number here. Okay? Alright. So let's look at other things that we can do with this little fact that we have, with this little conversion factors that we've just generated from all of our mole definition. Okay, so I can ask a slightly more complicated problem. So I can ask the question, how many atoms of calcium is in 105.1 milligram of calcium? Okay, so there's my question. This question is almost the same as the question that I asked above, except it's with a different number. But then I also have one additional conversion that I have to do. Last time I just went from grams to number of atoms. This time I'm going to have to go from milligrams to grams of atoms. So when you're faced with a problem like this, what you want to do is you want to sort of write down everything you know, and then you want to sort of think to yourself what kind of conversion factors might you want to use to go from one to the other. Alright, so what we're trying to do overall is we're trying to go from 105.1 milligrams of calcium to atoms of calcium. Now you might say to yourself, well, why is she bothering writing all that down? Well, what you find is, I think you'll find this true also. If you start writing stuff down and you sort of think while you're writing, you can sort of think your way to the final answer. So it's always a good thing to actually write down some of what you know, because then you can use that to get to the answers that you're looking for. Now, we are looking at this and we say, well, our Avogadro's number of atoms goes for 1 mole, and 1 mole goes to the number of grams of calcium for the atomic mass number that I get on the periodic table. Okay, so what do we know? Well, I can write down that definition that I have for the mole. So I know 1 mole of calcium, and this is one that we already actually wrote earlier. 1 mole of calcium is 40.08 grams of calcium, is equal to 6.02, and I'll just leave off that extra digit in my Avogadro's number. 6.02 times 10 to the 23rd atoms of calcium. Alright, so this is what we got out of the periodic table. Actually, since I have 4 significant figures, let me go ahead and leave that fourth number in my Avogadro's number there, because I want to make sure that I don't limit my my significant figures and my final number based on my Avogadro's number. Okay, so I got all of that. And then we also have this other thing that we had in chapter 1, where we said 1,000 milligrams is equal to 1 gram. All right? So those two lines are all the conversion factors that I'm going to use to go from milligrams of calcium to number of atoms of calcium. Very close to that promised question that you'd be able to solve, where you start out with the volume of water and go to the number of atoms of oxygen. Same sort of problem. Okay, so we're going to start out with the number that we have. So the number that we are given is the 105.1 milligrams of calcium. So I'm going to go ahead and write that down. So I got 105.1 milligrams of calcium. And now we are going to use the other numbers that we know. I'm going to stop at this point because I don't want to have you run into difficulty uploading the video. So I'm going to stop and then I'll continue.